Good morning. Today we're going over 8.2, which is arithmetic sequence notes. Now, to identify arithmetic sequences, that is the difference of a consecutive term in constants. This constant difference is called the common difference and is denoted by D. So what does that mean? If the numbers go up or down by a common number, then it would be arithmetic. So let's go over A and B to go over the example. So from 9 to 2, negative 9 to negative 2, that is a difference of plus 7. Now from negative 2, if we were to add 7, we land at 5. If we were to add 7, we end up at 12. And if we end up to add 7 to 12, we end up at 19. So A is in an arithmetic sequence. It has a common difference of 7. Now let's figure out if B is. We're going to subtract 8 on both sides. And that we get 15 because that's a difference between 23 and 15. If we were to take 8 away, we actually don't end up with 9. We end up with 7. So B is not an arithmetic sequence. Now, let's do 1, 2, and 3 just to figure out if these are arithmetic sequences. From 2 to 5, there's a difference of 3. If we add 3, we get 8. If we add another 3, we get 11. And if we add another 3, we get 14. So for number 1, D, the difference is plus 3. So it is an arithmetic sequence. I'm going to put a check mark for that. Now let's do B. Here we have to subtract 6 in order to get 9 from 15. If I take 6 away, again, I end up with negative 3. And if I take 6 again, I end up with negative 9. I kind of ate up one of the arrows, but that's okay. The difference here is negative 6 and is also an arithmetic sequence. So from here to here, we have to take away 4. If we were to subtract 4 minus 4 is not 2, it would have been 0. So 3 is not an arithmetic sequence. Okay, so writing rules of arithmetic sequences. So the core concept is rules of an arithmetic sequence is the nth term of the arithmetic sequence with the term A1, and the common difference is D, given by this formula. The nth term of the arithmetic sequence with the first term of 3 and a common difference of 2 is given by, this is an example. So what does this mean? We have this equation, or this formula. A1 is the first term. The AN term is the term you want to find. So the N stands for like the number. Let's say we want to find like the 100th term. That's what the N stands for, which is also what you would plug in here is that number. And D is the difference we just found. Now for the example, they simplified it from AN equals 3 plus N minus 1 times 2, or simplified into 2N plus 1. Either way, you would get the same answer. Now that we have the formula, let's try to do some examples. Alright, so I'm going to write the formula up here, just so we have it in this slide. And let's find the difference of 8 together. So, they want us to write the rule for the nth term of each sequence, then find the 15. So, from 3 to 5, it's plus 5. It's plus 5. So this is an arithmetic sequence. So we can go ahead and write the formula. So we want n15 equals, the first term is this first one, so 3, plus the n is for the term we're trying to find, so 15 minus 1 times 5. Now this is how we would solve it. So we're going to go ahead and do 15 minus 1 is 14, and then it's 14 times 5. So that's going to be, the 15th term is 3 plus 70. So our 15th term is going to be 73. Now, that is the solution. The rule, we would keep it as an, so it would be 3 plus n minus 1 times 5. You can either leave it like this or simplify it by distributing first to an equals 3 plus 5n minus 5, which then that becomes an equals 5n minus 2. Either one would be fine, that would be the rule, and this would be how to solve it. Now, take a second to solve B. We'll go over B tomorrow in class. Also, go ahead and solve example 4 by yourself, which is in the next page. We'll go over those two tomorrow in class. And lastly, the last concept for today's lesson is finding sums of finite arithmetic series. So the expressions formed by adding the terms of an arithmetic sequence is called the arithmetic series. The sum of the first nth term of the arithmetic series is denoted by Sn. To find the rule Sn, you can write Sn in two different ways and add the results. So we have Sn equals a1 plus d plus a1 plus 2d plus a1 plus 3d, and it's going to keep going on and on and on and on forever. So you can conclude that 2Sn is going to equal the m parentheses a1 plus an, which leads to the following result. This equation right here. This is what we're going to be working with. The sum of the first nth term of an arithmetic series is Sn, and then a1 plus an over 2. So in words, Sn is the main of the first and nth term multiplied by the number of terms. So in the last couple of slides, we figure out how to find an. So we find an, and then we're going to plug it back into this equation. Now let's do a few examples, one or two examples, to go over this. So here we want to find the sum of the arithmetic sequence. They want to find the sum of this. So max 20, and then the minimum is 1. So let's go ahead and plug it in. So Sn, so S20, because that's what we're trying to find, equals 20 times the first term. Let's figure out what it is. So a1 is going to be 3 times 1 plus 7. All I'm doing is plugging this 1 into the I to get 3 plus 7. So that's going to give me that the first term is going to be 10. So I'm going to go ahead and do 10 plus, let's find a20, which is the last one. So 3 times 20 plus 7. So that's going to be 60 plus 7. So it's going to be 67. After plugging it in, we're going to divide this by 2. So we get that the term S20 is 20 times 77 over 2. I'm going to cross simplify right here. So I get that S20 is actually going to equal 770. Now, try these 3 on your own, and we'll go over them in class tomorrow. But that's it for today's class. I want you guys to practice on these, and we'll go over them. If you understand and you're able to finish, please go ahead and start your homework. It should be on Canvas. So it is on Canvas already, but it is important that you understand this. See you guys tomorrow.